Here we are solving more trig equations. These trig equations, it tells us to find all solutions, which means we're going to squeeze in the plus 2 pi n after our answers here. But there's all my work, all my answers for those 4 problems. What we have to use on these as well, because they all have squares in them. And so we're going to be using the Pythagorean identities. The sine squared plus cosine squared equals 1. And you got all 3 of them right there. We're going to need some of the other ones as well for the trig identity type problems. Okay, so I'm going to work out letters B and D with you, and then from scratch, and then we'll just talk through the others. Okay, so what you got to do is the one that has the square in there, you're going to replace that one. All right, so we know sine squared plus cosine squared is equal to 1, and if I'm replacing cosine squared, I'm just going to subtract sine squared from both sides. So cosine squared is equivalent to 1 minus sine squared. Now see how that negative is right there? That negative is just there. And they're going to replace that cosine squared with the 1 minus sine squared. And then everything else is just going to carry down. Okay, so you don't care that one of them is squared and the other one's normal. It's just like you have an x squared and an x, we're going to be able to solve that equation right there. All right, now with this negative in front, I'm going to need to distribute to clear out the parentheses. So let's distribute the negative. And then I have a sine squared here. And then so this is just like a quadratic where you're going to have everything on one side set it equal to 0. So I have a sine squared plus 2 sine of x. And I have -1 plus 2, which is going to give us a positive 1. And then that's equal to 0. Now, what I'm working with here, this is a quadratic type. So you're going to factor this the same way you would x squared plus 2x plus 1, right? If you factor that, I think every single one of us knows you put a 1 there and a 1 there, and you put a plus and a plus. That'll give you your x squared, that'll give you your 2x, and that'll give you your positive 1, right? So I'm going to do the same thing here. Instead of the x's, though, I'm going to use the sine of x. So we're going to go sine of x plus 1, sine of x plus 1. And you could check yourself with your distributive property. If you go sine times sine, there's our sine squared. You're going to get a 1 sine of x plus another sine of x to get your 2 sine of x. And then 1 times 1 will give us that positive 1. So we did that correctly. Now, a lot of times we'll have 2 different things right here. But if you have the same exact thing there, usually we got 2 different things, and we'll take each one and set it equal to 0, and we'll get several answers. But if you have just one thing, you don't need to do it twice. So just take that one thing and set that equal to 0. So we're going to move the 1 to the other side. And then remember, the sign is your y value. You're thinking on your unit circle, where is our y value equal to a -1? So you're thinking about your quadrant, you're thinking about this point right there, where that y value is equal to a -1. These 2 dots, your y value is equal to 0. Up here, your y is equal to a positive 1. You have a -1 right there, so those signs are important. And so this angle is 3 pi over 2. So our answer, we're going to get 3 pi over 2. If the directions just say in between 0 and 2 pi, that's it. But if it says find all solutions, you got to squeeze in plus 2 pi n. So there's your answer right there. Let's now do letter D. Letter D, you have a sine squared and a cosine. You have to go to the one that's a square, and you got to change that one because the squares, we have the formula too. So if I want to solve this for sine squared, I'll just subtract the cosine squared over. So sine squared is equivalent to 1 minus cosine squared, and that's what I'm going to do. So the -2 is there, and I'm going to replace the sine squared with the 1 minus cosine squared. That plus 3 cosine of x carries down, and then that equals -3 is going to also carry down. And then I'm going to distribute the -2. Negative times negative is going to give me a positive here. All right, now you got like an x squared and an x, all right? It's a quadratic. Any quadratic, you have to move everything on the same side, set it equal to 0. So I'm going to move the 3 over here. So I'm just going to carry down the x squared part, the 2 cosine squared plus 3 cosine of x. And I'm going to add 3 to both sides. So if I go -2 plus that 3, that's going to give us a positive 1, and then that's going to equal to 0. Now, what you're solving this as, you're solving this like it's the quadratic equation, 2x squared plus 3x plus 1, right? So let me review one way of factoring that. Every one of you has like a different way that you're going to factor that. So usually what I go is I'll go straight to that answer, and I'll factor it. I'll put my 2 cosine of x right there. I'll put my cosine of x right here. That's a 1 right there. That's easy enough. That means those are going to be 1s automatically. And if this sign is a plus, that means those signs are going to match. And since that's a plus, then I could have put a plus right there. Now, usually once I factor that like that, though, with the number in front, I always like to check myself with that derivative property. So if I go 2 cosine times cosine, that gives me my 2 cosine squared. Then I get a plus 2 cosine of x plus another 1 cosine of x. There's my 3 cosine of x. And then 1 times 1 will give us that 1 right there, okay? Or if you want to factor this first, one other thing is like that bounce technique where we took the 2 and we times it by the 1. We made this x squared plus 3x plus 2. And then you factor this easier trinomial with the no number in front. So you can make this x plus 2 times x plus 1. And then if you multiply it by 2 at the beginning, though, sometimes you guys forget to divide it by 2 at the end of it, and then you reduce the fractions first. So 2 over 2 will give us 1. And then once you can't reduce no more, you take that bottom number, you slide that up, and then see that still gives you your x plus 1 or your cosine of x plus 1, and then your 2x plus 1 or your 2 cosine of x plus 1. So just be careful with your factoring skills there. And then once you have two different things, and we're going to set now both of these equal to 0. So right here, we're going to move the 1 over, divide by 2. Be careful with your signs. It's going to be a negative 1/2. And when you move the 1 over here, you get cosine is equal to a negative 1. And so this is just like the one we just got done doing with your quadrant angles. You're thinking on your unit circle, where is your x value equal to negative 1? That's right there. That's pi. So this answer is going to be pi plus 2n. Because it says find all solutions, you gotta squeeze in that plus 2n. So we got pi plus 2n as one of our answers. And then this here, this is your stuff with your quadrant and your reference angle. Think quadrant and reference angle. Where is our cosine negative? Okay, use your all Snickers taste chocolatey. Cosine is positive 1 and 4, which means cosine is negative in 2 and 3. And the reference angle from your chart, where your cosine is 1/2, that's at the pi over 3 as the reference angle. And this is just your 1 more, 1 less stuff right there. And so here we'll get x. Remember, your quadrant 2 will be 1 number smaller on the top, but you got to squeeze in a plus 2 pi n. And then your quadrant 3 angle would be 1 number higher on the top, and we got to squeeze in the plus 2 pi n. So then you get 2 more answers right there. And then as you look at the other ones, C is very similar to letter D. You replace the cosine squared with the 1 minus sine squared, distribute, combine like terms, get everything is already on one side. So I just go negative 2 plus 1, got a negative 1 there. And then when you're factoring this part, if you have trouble with that factoring, you know, just think that you're factoring that as like a 2x squared minus x minus 1. If it helps you to do the bounce technique or one other way that you guys know how to do, then you got x squared minus x minus 2. You could factor this as x minus 2 times x plus 1. And then since I multiply by 2, I got to divide by 2 at the end. So this will give me x minus 1. Then I could slide that up and I get the 2x plus 1. So notice I got a 2x plus 1, x minus 1. And then right here, I got a 2 times sine of x plus 1, sine of x minus 1. Just replace those x's with the sine of x's. And then we'll set each one equal to 0. Your sine is negative in 3 and 4. Reference angle where your sine is 1/2 is pi over 6. So you got 7 pi over 6, 11 pi over 6. You're 1 number higher. And then your double it, subtract 1. Squeeze in a plus 2 pi n, and then where my sine is equal to 1, that's where the y value is equal to a positive 1. That's at pi over 2, and then you squeeze in the plus 2 pi n. On letter A, it doesn't matter which one you switch. You could change this cosine squared to a 1 minus sine squared, or you can change that sine squared to a 1 minus cosine squared. It doesn't matter when they're both squared, okay? So it's not like the double angle form is where it matters which one you change there. It just doesn't matter. Just pick one and go with it. It'll work out either way. But on this one, you get cosine is equal to a plus or minus 1. So you're thinking on the unit circle, where is my x value either equal to a positive 1 or a negative 1? And that's at those two spots, the 0 and the pi, and then you squeeze in that 2 pi n. So